So what I'm going to go ahead and do is start talking about an example of using cross sections to find the volume of some solid. So we're going to start off by looking at a region that's bounded by y equals x plus 1 and y equals x squared minus 1. The important part here, though, is that we pay attention to the cross sections are, and this symbol means perpendicular, to the x-axis. Now, that's the important part right there. Since this is the x-axis, what I'm going to do is I'm going to use functions in terms of x. If this said y-axis, I would use functions in terms of y. Now that I've got that done, I want to go ahead and look at the first part of the example, which says find the area of the base. That's a review question because we're just going to find the area between those two curves. So here I go. First one is y equals x plus 1, which is a straight line. The y-intercept is 1, the slope is 1, so it's going to go up 1 and right 1, up 1 and right 1, up 1 and right 1. It's also going to go down 1 and left 1, down 1 and left 1, down 1 and left 1. And so I'm going to do my best to go ahead and draw this straight line. It kind of looks something like that. And there's y equals x plus 1. Now I'm going to go ahead and do the other one. It's a parabola. Hopefully you guys figure out pretty quickly. If I plug in 0, we get negative 1. If I plug in positive 1, 1 squared is 1, minus 1 makes 0. Same thing is going to happen if I plugged in negative 1. If I plugged in 2 or negative 2, I'm going to get 2 squared, which is 4. Minus 1 is 3, so it's going to be there and there. And so my parabola is going to look something like this. Maybe not exactly, but it's pretty close. So y equals x squared minus 1 is that. So the base, the area that I want to find, is this region in here. Now hopefully you guys notice I have two intersection points. One of them is here at 2, 3. The other one is back here at negative 1, 0. Since we are using x's, it's going to be easier if I just focus on the x value of those intersections. And so I'm going to do the integral from negative 1 to 2, this negative 1 to that 2, of the top function, which is the blue, x plus 1, minus the bottom function, which is the red, which is x squared minus 1 dx. Now, I'm going to go ahead and distribute the negative and start working on this problem. So from integral from negative 1 to 2, distribute the negative, we're going to have x plus 1 minus x squared plus 2. All right, I'm going to go ahead and rearrange and start combining like terms. I'm going to do the negative x squared first. Then I've got 1x. Then, I put a 2 plus 1. So that should make it 2 down here. All right. Now I'm going to go ahead and integrate. That negative is going to be, or negative x squared is going to become negative 1/3 x cubed. X is going to become 1/2 of x squared plus 2x evaluated from negative 1 to 2. So let me go ahead and plug in 2. Negative 1/3 of 2 cubed plus 1/2 of 2 squared plus 2 times 2. All of that is going to be subtracted by, if I plugged in the 1, negative 1/3, it's a negative 1 cubed plus 1/2 of negative 1 squared plus 2 times negative 1. All right, let's see what happens. So that's going to become negative 8/3. 2 squared is 4, and half of that is 2. 2 times 2 is 4, minus, that's negative 1 cubed, which is still negative 1, and there's already a negative 1/3 there, so that's going to become positive 1/3. Negative 1 squared is going to become positive 1, so that's a positive 1/2, and then that's going to be a minus 2 here at the end. I'm going to go ahead and start combining some of these terms, and just pay attention to the fact that when I go ahead and distribute this negative, it's going to help work things out a little bit better. So this is going to be negative 8/3 plus 6 minus 1/3 minus 1/2 plus 2. So I'm going to go ahead and start combining again some of these. Negative 8/3 minus 1/3 is going to make negative 9/3. 6 and 2 makes 8. I'm going to leave that 1/2 alone for a second. Come back to negative 9/3 is negative 3 plus 8 minus 1/2. Negative 3 and 8 makes 5 minus 1/2 makes 4.5. You could also write it as 9/2. Either one of those work, but that's the area that I wanted from that first example. I'm going to come back in a second now that I've got it graphed and start talking about these other examples because, again, this was kind of a good review of what we've done previously, and I wanted to do the new stuff a little bit separately. So here I go. I'm going to be right back.